Well, welcome back to the Cloud Plus 2024 refresh so we can get this um, up to date. So, um, once again, this is Cloud Plus CV0-004. Came out in July of 24. I'm recording these in September. We've already covered page 1 and 2. We're on to page 3, which is where the bulk of it's at. So we're going to start with cloud architecture. Probably going to do 3 videos in this section. This first video, I aim to cover these first 4. Okay, so if we look here, cloud architecture, we'll cover given a scenario, use the appropriate cloud service model, as well as explain concepts related to service availability, explain how cloud networking concepts, and compare and contrast storage resources and technologies. Let's get started. So, given a scenario, use the appropriate cloud service model. So this is really cool. In fact, I have a great example to show you. Let me get it. Okay, I got those loaded above, but let's talk a little bit about the cloud service models. So we're going to look at as a service, the pizza by Paul Carrison. Hopefully it'll help. But so we have infrastructure as a service, containers as a service, platforms as a service, function as a service, software as a service. There's kind of an X as a service, like everything as a service. Anyway, so pizza as a service. This is a way to try and understand it a little bit from a non-technical standpoint, because sometimes it's really hard for people to understand. So we have this pizza as a service model that has come up with. I'm going to link to this down below, but he's been kind enough to give me access to this larger version. So once again, I'll link to this down below. So this is kind of as a service model if we looked at it as making pizza. Okay, so we have homemade, which is the legacy way of doing it. We have a communal communal kitchen, bring your own takeaway restaurant party. You can see as we go up the as a service model, from legacy all the way to software as a service, there's fewer things that are taken care of by the that you manage versus the vendor manages that you're buying it from. Okay, so we can see that when you're thinking about going into cloud computing, one of the things you should think about is how much of this do I want to do? How much is it of it is core to my business? And should I push some of this off? Okay, so this is where, sorry, I had to find the right image I wanted to use, but that brings us to the technical version of it. So, and I'll link to this down below as well. So you'd have traditional on-prem where you're doing the hardware virtualization, OS runtime, scaling, application code, data, and configurations. And as you go up the as-a-service model, eventually you're only taking care of the data and the configurations. In fact, you're only taking care of the input of the data because the backing up of the data is taken care of already. So it's really cool how this progresses. But you're going to be paying more for this because the cloud provider is managing all of these things. Okay, so you're going to have to understand kind of the difference between these. This is where, really understanding a model like this, so that the hardware, only in the first one you're managing it. Infrastructure as a service, you're now managing the OS. Containers as a service, you're managing the runtime. Platform as a service, you're just doing the scaling up and down. Application code, then data configurations. So you're doing less of the work and more with paying money so that other people are doing the work as you go up the ladder. Cool. So as you're thinking about this, you need to be thinking about, okay, how much is this going to cost? What controls are in place to make sure that we're comfortable moving it up? Features. What are the features that we're getting? And what policies do you need to be concerned about internally? So you can do subscription services. for some things. You can subscribe to file subscriptions, communications. So email's a big one that a lot of people are doing. SaaS, where you have Office 365 or Gmail for Business. Now, just because it's Gmail, so if you have a at gmail.com, that's probably not SaaS. It's just a service. But some of these can come with subscriptions. Other of them, you're collaborating. And then you have things like virtual desktop infrastructure, directory, and identity services that are challenging. So explain concepts related to service and availability. So higher availability, high. I always say higher because obviously we want our stuff up all the time, but it's hard and it gets to be more costly the closer to 100% you get. So we're always trying to get a little better, higher, but it's referred to as high availability. Disaster recovery. If something bad happens and things are taken out for whatever reason, how are you going to recover? Fault tolerance. If something bad happens, are you able to just keep going and no one notices because you're architected in a way that allows your service to stay available even when something bad happens? Load balancing. Have you set things up so that there's multiple systems behind the scenes? And hey, if you need to do an update, for example, you can pull one system out, patch it, put it back in, and see if it's good. Meanwhile, all the other servers are handling things. If it's good and starts processing things with no errors, then you can patch the next one stuff. Load balancing gives you a lot of flexibility. It helps bring in the fault tolerance and gives you higher availability if done right. It adds complexity. So you've got to really understand it. Scalability. Can you handle the load? If there's increased load, how are you going to manage it? So is this something that can scale vertically or horizontally? Vertically would be we're going to have to put it on a bigger system. Horizontally is we just spin up additional nodes. So and of course, things that scale horizontally are a lot easy to automatically manage by like monitoring and alerting. Something happens, you see an increase in load, just automatically spin up an instance. But you need to be monitoring and alerting as well to help with your service availability. Deploying things. So some things that help in striving for this higher availability is deploying virtual machines and custom images. So for example, you might take templates of an OS or solutions or their kind of recipes that you apply on install that help get things to where they need to be. Identity management. Are things tied to a local, to a repository of identities so that when it spins up, you can not have to create all the different accounts. It's already done and it works because you have an identity management system that's helping to auto-populate things and manage credentials that are allowed onto the systems. So containers, are you setting them up so that they're done well? The variables are in the configuration. The secrets are stored in the right place so that hackers don't get them and use all your funds. Is the storage, does it need to be persistent or can it go away when the system goes away? Because everything that's needed is stored elsewhere. Setting things up so that you can auto scale, right? So ideally, if you have the need, it just starts up additional resources so that you don't have to worry about it. And after they've been deployed, it automatically validates to make sure things are going well. So the next part, we're going to explain some cloud networking concepts. So we're going to drill in a little bit to VPN, services, network, and routing, and a little more. So VPNs. You might have a site-to-site VPN or a point-to-point or a point-to-site. These are all different. So a site would allow everything from one side and everything from the other side to talk back and forth. So that's if it's trusted areas to trusted areas. Usually you don't want to trust entire areas. So it might be this one thing can talk over to this one thing, but that's a lot of things to manage and can easily have little mistakes. So you might do a point to a site or an IPsec tunnel. Multi There's also the multi-protocol label switching, MPLS. Okay, services. Of course, you want to enable something like DHCP if you're going to have things automatically spin up. They get their IP addresses automatically, or set them up so that they're assigned the proper ones if it's not DHCP. You should always have network time protocol kind of running locally and everything syncing to it, so that when something bad happens, which it does, all the times will be similar, so you don't have to try and understand what happened when on what system because the times are different. DNS, make sure your domain names are automatically registered in your domain name system, and only the ones that you want to be public are public. You might want to have a content delivery network so that things that are not frequently changed can be accessed from anywhere in the world closer to the person, so it's less latency. And then IP address management. That's just the local IPs. So network and routing, virtual routing. So dynamic and static routing is something that you should be familiar with. Virtual network interface controllers, VNICs. So that would be in virtualization. Subnetting, able to create different, we call them zones. I'm trying to think of a way to say it in a non-networking term, but kind of like different buckets or containers for systems to be in because they're similar. Sometimes you want to break it so that it's really small and you can do a lot of the protecting at the smaller layers. Load balancers, firewalls, these appliances that can help you achieve those higher availability and more resiliency in your systems. And then in public cloud computing, you have the ability to make virtual private clouds, and you can set them up and have them hub and spoke or pair them together. So because you're not building an individual data center for you, and you can do virtual ones, you could set up a lot of them. You don't have to stick with one big VPC. In fact, that's usually the wrong way of doing it. But that doesn't mean you should go the exact opposite way and do basically a VPC per system. That would be also the wrong way of doing it. So find a happy medium in your deployments. So there's some other stuff that you should probably be familiar with. So VLANs, VXLANs, Geneve, and so these are extended for vMotions going between different data centers type stuff. Software-defined networks, so that you can put things in, it automatically configures. You can do more of a zero trust when you're doing a software-defined network and not having to wait for people to set things up. Single root in-out virtualization. So compare and contrast storage resources and technology. So this is where I wanted to check out S3, and I actually did some of this just yesterday. I'm re-recording this video, or the day before, and things have already changed. Not at the next tab, so we'll try it again. But Amazon S3 has all these different storage classes, and that is just one small aspect of AWS storage options. So you have standard intelligent tiering, express, standard intelligent access, one zone intelligent access, Glacier instance retrieval, Glacier flexible, Glacier deep archive, S3 outposts, and performance charts. So there's lots of storage stuff, and that's just S3. We can kick it back up to storage, and there's even more information here. So once again, I'll link down below. So I did a Google search on storage, and Google's changing so quickly lately, and it threw this up, kind of cool. And one of the things with storage, I really think you should understand the difference, which options are object storage, which options are block storage, which options are file storage. That will help with some of the questions that you're asked. So it's funny because I did the same Google search just before this video, and that's gone now. But anyway, there's different storage options, and yeah. So Google keeps changing, so that's why it's good to take a screenshot. There are lots of options here that would be good to have a general understanding of. I mean, I love the Snow family storage options. They're just kind of cool, especially when they drove the semi onto the stage. It's one of the coolest conference events I've been to. So let's see, storage. Block. That's what all like local OS systems are usually running on, is block storage. It's the zeros and the ones. Now sometimes you have a drive mapped to network storage. That's network attached storage. So in AWS, that would be like an EFS, Elastic File System, is a network attached storage. Block storage is more of the EBS, Elastic Block Stores. Just think Elastic is on a lot of these, and then what they are, and then stores. Anyway, EBS, EFS, or system, Elastic File System. So object stores. This is where it's interesting because these are usually there. You can be them. They can be web addressable. So this is like your S3. So there's often tenants or buckets here. So there are different types of disk as well. So you have the for block, you have the flash, the hybrid, the spinning, the long term. And with that, oftentimes public cloud providers will give you options to buy from those, which comes to an interesting point as to why public cloud providers are so helpful, and that is they can afford to have a lot of different options. And if you're a smaller company, you can't afford to have and to operate a decent number of options sometimes. So it's just sometimes best to go with a public cloud. But you can do a private cloud as well. So depending on your size, it might be right for you. So protocols, network file systems, common internet file systems, internet small computer system interface, iSCSI, fiber channel, and non-volatile memory express over fabrics. So those are the main ones that I'm aware of that you should be aware of. And some of these might be I should probably double check and make sure I'm good with some of them. It's always great to refresh the RAID levels. The main ones that you should know is 0, 1, 5, 6, and 10. 0 is just a bunch of disks. So that's basically you have two disks together and you use them just as normal disks, so it's just extra space. 1 is mirroring, so it's slower write, but it's safer because if one dies, you're good with the other. 5 is parity, and parity is kind of cool because when you're storing ones and zeros, what happens is if you have a bunch of ones and zeros, you can just do math. And every time you hit 1, go back to 0. And so you just have to have one extra disk, and you can back up 10 disks with 1. And if you lose 1, then that 1 can tell you what was lost. Now, oftentimes, if you had 10 disks, you probably want to have more than just 1. So that comes into 6th, the second parity. So if you have 10 drives, maybe use 2 of them for parity. So with the 1s and the 0s, 2 of them is just the math. So that if you lose 1, okay, you're fine, and you do the math again, then you can lose another one while you're waiting to get the replacement, and you're still okay. Just chasing the 9s, trying to get closer to 100% uptime, which is not really achievable. We're all going to make mistakes, but you get as close as you can. And 10 is basically it's 0 and 1 together. It's mirrored and just a bunch of disks. Okay, so additional features we should be thinking about with storage. So you can compress things. Now, in the past on spinning disks. That was a bad idea because the biggest issue we had is how slow the disk was, and now you're putting more on it, and the traffic jam is even worse. Same with deduplication. It's the same thing. In the old days with the spinning disks, putting more on it because you're not going to store the same thing more than once. And a lot of space is wasted because you have OS that's just the same stuff installed over and over and over again. But it only makes sense to deduplicate and compress if you have fast disk. In fact, you might want to not compress because it might slow things down, but you might want to deduplicate to save space. So just think about options. Thin provisioning. So you might only provision what you use, and then as your OS needs more, it has to actually go and get it, and you get these little chunks. And think about it as when your old disk drives, when you had to defragment them, basically the different parts of the file ended up far away from each other, and it had to search and find them. Sometimes you just need to bring it back together, even with the thin provisioning. So thick provisioning, you give the disk, all of it, to the virtual machines that are underneath, and just they have it, so they don't have to go over the overhead to find extra space the next time they need to grow. And then you have replicas. On top of that, we have user quotas, limiting the space that people can use. Hyperconverged is like storage nodes. It's on-prem and in the cloud, so you have both. Software-defined storage. It's easier to change out under the hypervisor, so you can just swap things out and it doesn't notice as much. So, okay. So next time we're going to cover Cloud Architecture Part 2. I hope you've enjoyed this, and we'll see you in the next one.